Okay, so now we're going to talk about how to graph or solve rational inequalities. So, for example, here is the graph of this inequality, but the thing is we're looking in this case where our equation is less than 0. Where is this graph going to be underneath the x-axis? So where is this less than 0? So this means that I want all of these pieces underneath the graph. So we see that we're going to have two pieces, but we don't really know what those pieces are. And so what we need to do in order to figure out what those pieces are is we have to find every vertical asymptote, and we also have to find every 0 or x-intercept. And that's going to divide or split our graph into a bunch of different segments. So how I find the vertical asymptote is strictly based on the denominator. And so when I look at this denominator, if I were to factor this, I need two numbers that multiply to a negative 12 that at the same time would add to a negative 1. So this would be a negative 4 and a positive 3. Negative 4 times 3 is negative 12. Negative 4 plus 3, negative 1. So that is the factored form, meaning if I set each one of these equal to 0, we would say, hey, we have a vertical asymptote at x equals 4 and at x equals negative 3, right? So opposite sign, boom. Opposite sign, boom. So we have two vertical asymptotes. So we're going to go ahead and split that. So at negative 3, 1, 2, 3, we're going to have a dotted line here. And then finally at 4, so here, we're going to have a vertical asymptote here. So our end behaviors, the leftmost side, the rightmost side of our graph, never going to cross these vertical asymptotes. Now, same thing with the end behavior of the horizontal asymptote as well. Finally, x-intercepts. In order to find the x-intercepts, you need to look at the numerator. So vertical asymptotes and wholes, we look at the denominator. X-intercepts, we look at the top of our fraction, the numerator. Well, if I take my numerator, x squared minus 1, and I set this equal to 0, I add 1 to both sides, so I get that x squared equals 1. When I take the square root of both sides, I get x equals plus or minus, square root brings out the plus or minus. The square root of 1 is 1, right? 1 times 1 is 1. So I have two x-intercepts, which kind of makes sense. But my two x-intercepts are positive and negative 1. So what's going to happen is this graph is actually crossing right here and right here. It's just a little bit harder to see. So we're going to actually split this up into, now this is not an asymptote, so I don't want you to get that confused. But really, typically, what you'd have to do algebraically is you would have to split this up into these sections. So I have one section here from this vertical asymptote all the way over to negative infinity. I have this section in between the vertical asymptote and the x-intercept. I have a third section in between the two x-intercepts, a fourth one from this x-intercept to this asymptote, and finally a fifth one from this asymptote all the way to positive infinity. So we have 5 sections. So if you were to do this algebraically, you would have to test a value in each of the 5 sections to see which one works. So not only do you have to do all of this work, but then you have to test 5 coordinate points. Well, we're not going to do that. What we're going to do is look at and see where is this below my x-axis. Where is this less than 0? Well, it looks like it's less than 0. Do you see this? It looks like it's less than 0 right here. And it looks like it's less than 0 right here. So we have 2 sections where it's less than 0. So where is this inequality going to be true? Well, it's true from all of my x values not equal, well, I'm sorry, it's not equal to 0, so it can't be equal to 0. So not equal to this vertical asymptote, so it's from negative 3 all the way up to negative 1. So this little x value chunk. So this is going to be true. It's going to be underneath the graph, underneath the x-axis from all my x values from negative 3 to negative 1. So let's go ahead and write that. We're using parentheses because it cannot be equal to it because I don't have an equal to sign. So all the x values from negative 3 to negative 1, not equal to. Or we're going to have solutions in this section where it's underneath the x-axis because here it goes just above. That's why it's hard to tell. But that's why you need to figure out where your x-intercepts are so you don't make the mistake in thinking that it crosses at 0 and so it's everything below that. My next piece is going to be from positive 1 all the way to positive 4 where this asymptote is. So from where it crosses the x-axis at positive 1 and it goes down from there all the way to positive 4 at that vertical asymptote. So 1, comma, 4. And this would finally be our answer. So in order to solve an inequality, first we want to figure out where are our vertical asymptotes and where are our x-intercepts. Once we do that, that splits it up in the different sections that we're looking for. And then within each section, we're trying to figure out, is this above that x-axis or is it below that x-axis? Am I going to use parentheses because it's not equal to 0, or am I going to use a bracket because it is equal to 0? Be careful with infinity, right? If we had positive or negative infinity, we'd use a parenthesis to describe that.